science classes are. But this is
Alrighty.
What do you plan? What do you do for the like what
cross country plan.
country plan?
Yeah, I'll give you a run.
All right. So I got the recorder turned on, and let me go ahead and get started. I did not plan very well, because I did not realize that I'm running out of time for the second exam. So what I'll do today is to talk about the practice exam, which is the exam two from the spring semester. And I do apologize that I did not, give you guys enough time to kind of like, okay, let us take a look, over the weekend, and then we'll talk about the answers. So I'm just going to go straight into the exam from spring 2022, because I want to have our exam on next Monday. Okay, so that means we still have one more class meeting before the exam. So if you guys have any questions when you study, you can still bring those questions to me, and I still have office hour like every day in the week. So, you can contact me if you have any questions. All right. So with that said, let me go find those practice questions first.
You've only had one test at 4:30, right?
Yeah.
And then I missed a couple of class sessions.
Yeah, it was like one like five live exams and then the two slides, the two like quiz.
All right.
You were saying it's 45 seven.
So I'm gonna bring this. Oh, okay, that won't work. Okay, try it one more time. All right. So this is an example or sample of exam two from spring 2022. Um, your format is going to be about the same. So the exam time is going to be the entire period of the lecture, just like with exam one. You know, we are not. I'm not too concerned about this course because yours is going to be once again paper only. So we'll go over the questions. So this is the first question. This one has to do with relations. So question number one is asking, I give you a specific relation, and it is defined over x, which is 0, 1, 2. Describe relation R in the following terms. So you have to tell me whether it's true or false. Do not leave it blank. If it is false, point out why it is false using a specific counterexample that makes the applicable quantified criterion statement false. All right, so let me just stop here because the question is, what are we talking about? What is the quantified criterion statement when we talked about relations? Any ideas? Okay, where would you go? I'm looking at, I'm trying to find the right page that has, okay, this is good. So we're going to go back to the lecture, the module that relates to relations, which is this one here. And this is the module. This is when we talked about relations. Now, this test is just like the first exam. It is open book, open notes. So that means you can bring as much material as you think will help you. Um, and if you look up additional material and you find something that can be helpful, you can bring that too. So let's go to relations. And we have these four main properties that we need to deal with. So let's start with reflexive. All right, so let's just look at 5.1. Where do you think is okay, let me repeat the question. Where do you think is the quantified criterion statement? First of all, what do you mean? What do you think I mean when I said quantified? Come on, you guys should know that answer. It uses a quantifier. Okay, very good. And how many quantifiers have we talked about in this class? There are two. One is called For each, okay, for each, for all, or every, they are basically the same. And what is the other one? There exists, or some, right? So all, you can describe that in either one. So in normal English, okay, the for all is the same thing as every. And then the sum is basically the same as there exist. Is that okay? All right. So on the screen that you are seeing here, let me get rid of the horizontal tab. Okay. So on the screen right now, where do you find the quantified criterion? What is a criterion? What do we use a criterion for? To define, to qualify something, right? You have to meet the criterions to be blah, okay? So now we have quantified criterion. So where do you think is the quantified criterion, statement for being reflexive? There are only 3 lines under reflexive, so just name one of those 3 lines as your answer. Line 1, line 2, or line 3? Line 2. That would be the correct answer. Okay, so that's how if this particular statement is true, then the relation R over X is considered to be reflexive. Is that okay? So the question now is, if I give you a relation that is not reflexive, I'm going to ask you and ask, well, obviously, if it is not true, if a relation is not reflexive, that means for at least one element in X, this particular statement is false. Is that making any sense? Okay. And the question is basically saying, if a relation is not reflexive, tell me why it is not reflexive, but using the definition of reflexive itself to look at the counter examples. Are we doing okay so far? All right. So let me switch back to the question. So this way we can. Oh, okay. I forgot to turn on Discord because I have one student online, and I keep forgetting this. Okay. All right. So getting back to this question here. Let's go back to the question, the practice question, which is over here. All right, so first of all, what would be the answer for reflexive? This is the relation, this is X. The question is R reflexive over X? It is. Okay, so in that case, you do not have to give me a counter example because the counter example does not exist. A simple answer of reflexive, true, is going to be sufficient. Is that okay? Yep.
Are we having an exam soon?
Next Monday. Because the second exam is supposed to be about 2/3 through the semester. So if you multiply 16 by 0.666667, that gives us about, this is about the right time for the second exam. If I push the second exam too much far out, then it'll be too close to the final exam, and I don't think that's going to be good either. Yep. So next Monday is going to be our second exam, or exam 2. All right. All right. So for reflexive, it's just true. How about symmetric? So how do we know whether this relation R is symmetric? All right. So what makes a relation symmetric? And you might have some idea based on your understanding of the word symmetry. Don't count on that. That's all I'm going to say, okay? Do not count on your understanding of the word itself. How should you go about doing this?
By the rule.
by the rule, by the definition. So what you need to do is to just do what I did earlier, which is go back to the module, and this time we focus on 5.2. What makes a relation symmetric? Well, a relation is symmetric when this is true. Okay, when the quantified criterion statement is true, then it is symmetric. So in this case, we have, for all EF in X, EF is in R if and only if FE is in R. Okay, so this is the definition. And if we switch back to the exam and look at the actual relation that we are looking at, the question is this symmetric? And if it is not symmetric, how am I supposed to answer the question? Okay, so those two are the things that I want you to think about right now. Is this R? Okay, let me highlight the R first. So the question is this R symmetric? And if it is not, how should we answer the question? First thing first, is it symmetric or not?
Yes.
No.
It is not symmetric. Okay, it is not symmetric. So now that we know it's not symmetric, what do we know? So let's go back to the definition. If we know it is not symmetric, that means I should be able to find EF in X such that EF is in R if and only FE is in R is false. I want you to tell me exactly what F and E are supposed to be, or at least one case. Okay, there can be multiple cases. I just need one, so that I know that you can relate your answer of false to the actual definition of what is symmetry. All right, so let's go back to the example. I think I might want to display both at the same time. Okay, I'm just thinking about how to look at this, how to display the questions. I think I can do it this way. Give me a second. I'll do a screenshot because I need to refer to this like multiple times. So I'm just going to take a screenshot of just the expressions and then open it in Fair and then make it always on top of other windows. Then I can switch to the other tab and this one stays put. There we go. Okay, this is nice. Okay, so now the question is, we know it is not symmetric. The question is, what value should I pick or choose as E and F so that this condition here is false?
0 and 1.
Hmm?
2 and 1.
Answers. There are several answers. So you can use 1, 2. 1, 2 will work because 2, 1 is here, but 1, 2 is not here. But that is not the answer that I want. I want the answer as if E is 1 and F is 2, then 1, 2 is in R if and only if 2, 1 is in R is going to be false. Is that okay? Because I want you to quote the actual statement that is false inside the quantified expression. Are we good so far? Okay. All right, so symmetry is done. We move on to asymmetric. Antisymmetric. Yep.
How would you like us to write the answer for this question? So if
I
we were to
can-
write out the expression with 2, 1 is equal to false, or
I can give you an example. So let me open up the text editor. All right, so here's my text editor. Okay, so for reflexive, it's easy, right? The reflexive, you just say it's true. And then for symmetric, you say, when E equals to 1, F equals to 2, then E, F is in R, if and only if FE is in R is false.
I think we just want to write the definition.
Hmm?
We just want to write the definition.
Yeah. Yep. So I want you to, you can you can shortcut this, by using a definition somewhere. So, in the other questions, if you need to refer to the same thing, you can just kind of call out the label. The reason why I want you to kind of spell this out, you have to say false first. Because I want you to not just tell me intuitively it is false. I want you to tell me exactly why it is false. Is that okay? Um, so that's why. Are we ready to move on to anti-symmetric? So, yep.
Just a question, what's the mathematical operator for because? How would I use that symbol?
I
That just
think
implies,
it is this.
therefore? Oh, okay.
Yep, I think so, but you can always look it up. So let's look it up. Um, symbol for because. There we go.
I think I've been
Yep.
messing
So,
those two up.
so this is because, this is therefore.
Okay, thank you.
All right. Moving on. So let me close this. All right, so the next one up is anti-symmetric. And this is why I do not want people to use the intuitive understanding of the words, because anti-symmetric seems to say the same thing as not symmetric, which is not what anti-symmetric is about. Okay? So we should look up the definition of anti-symmetric, which is here. 5.4 is anti-symmetry. So now we have this kind of rather long thing, right? And I want to ask first, is this relation anti-symmetric or not? This one here. I think a few weeks ago we have all forgotten about the definition of anti-symmetry. It is not anti-symmetric. Very good. So the question is, what should I choose as the values of E and F such that this expression here becomes false? That's basically what I'm looking for.
0, 2?
Hmm?
0, 2?
0 and 2. That is correct. So the answer in this case, if I were to type it out, I know you guys have to write and I can type, so it's not exactly going to be as quick. So anti-symmetric is false because when E equals to 1 to 0, F equals to 2, EF is in R and FE is in R. Okay, I need to close this paren here, implies E equals to F is false. Do we see that? Yep, go ahead.
Wouldn't 2-1 works too? 2-1 for this one.
2-1 would not work, okay? Because, okay, so let's take a look what happens when E is 1 and F is 2. It doesn't matter which one is 1, which one is 2, because, you can see, this part here is actually quote-unquote symmetric. Okay, so let's plug that in. Okay, 1, 2, okay? E is 1, F is 2. So 1, 2 is in R is, well, let's take a look. So 1, 2 is in R is false. Okay, so now we have the left-hand side of the conjunction being false. So what would that do to the conjunction? The whole conjunction is going to be false. So the conjunction, the entire conjunction is on the left-hand side of the implication. So what happens when you have the left-hand side of an implication being false? What is the value of the implication itself? It's going to be true. So it's not a counterexample. So in order for a counterexample to happen here, you need the implication itself to be false. But when you look at the truth table of implication, there's only one row that makes the implication itself false, which is when the left-hand side is true and the right-hand side is false. So that's what we are looking for in this case. We need this conjunction to be true, but at the same time, we want this equality to be false. That would be the counterexample we are looking for. Yep.
So 0, 1 would work, right?
0, 1 is not going to work. 0, 1 is not going to work because 0, 1 is in R is false. I mean, it depends on what work means. It would not serve as a counterexample, yes. So it would not serve as a counterexample because 1, 0, 1 does not even exist by itself. So that makes the conjunction false. But when the conjunction, which is the left-hand side of the implication, is false, the implication itself is true. So this is a good one to kind of review because it really depends on implication. All right? All right, so getting back to the sample answer, this is the correct answer. 0, 2 is 1. 1, 2 is not going to work. 0, 1 is not going to work. So this is the only example. This is the only counter example that can be used. In some of the questions, there may be multiple counter examples. You just have to pick one. In this particular one, there's only one single one. Are we doing okay? All right. So the next one is transitive. Okay, so if you read the question, the next one is transitive. So now the question is this relation transitive over this particular x here? So transitive is defined in section 5.3. So I'm really asking whether we can find one particular case of putting values into E, F, and G such that this thing here is false. Once again, it is an implication, which means the only way to make it false is for the left-hand side to be true, but the right-hand side to be false. So now we're looking for this conjunction being true, and then for the EG here to be false. So what do you think? It is false, and what would be the counter example? What would you choose as E, F, and G?
E is 0, F
E.
equals 2, G equals 1.
Okay, so let's see if that works out or not. Okay, so this is for transitive, and you claim it is false. So we'll see whether that's going to be the case or not. So now we look at the definition. EF is in G, in R. Is that right or not? Do we have 0, 2 in the whole thing? The answer is yes, we do. And FG is in R. So do we have 2, 1 in R? The answer is yes, we do. So now we put a parentheses over the entire conjunction because we know the conjunction itself is true. So the question is whether we can find EG is in R, and that better be false. So EG is 0, 1, and 0, 1 is indeed not found in R, and as a result, this whole thing is false. So let me put an extra pair of parentheses around the entire thing. There we go. All right, very good. All right, so, but that's not the end of it. I think, let's see, it's not the end of it because we also have comparable. So comparable is not one of these. I guess I can go back to the notes and quote what is comparable. Comparable is not one of these, for a reason, because comparable is only needed when you want to go for a total order. So this is comparable right here. R is comparable over X, meaning that for all EF in X, ERF or FRE. So the question is that applicable to our question here? Let me also do a screenshot here so I can also make this always appear on the screen. That makes it easier to refer to it. All right. So one more step. There we go. Go back to the exam question. So now I'm asking you, can you find a value for E and a value for F so that ERF or FRE is false given the relation that we are dealing with here? Or there are two values that they're not related in any way. Well, 0 relates to 0, 0 relates to 1, or does it? 0 does not relate to 1, so we have just found our answer. So the answer to comparable, okay, let me go back to my text editor. So comparable is false because when E equals to 0, F equals to 1, I'm just moving it out of place, then um, 0, 0R1 or 1R0 is false. Is that okay? So for the ones that are true, it's easy. You just say true. For the ones that are false, then you actually have to give me the counter example. What makes it false in that particular question?
So 0R1 or 1R0 is, um,
Okay, so this is a notation issue. So 0R1 is really saying the same thing as 0, 1 is in R. It's just a different way to refer to the relation. Mhm. So are we good with question number 1? So there are several questions related to question number 1, or they have the same format. Okay, let's look at question number 2. Question number 2 has the same format. Let's find the answer. Is it reflexive? In question number 2, is that R reflexive? What makes a relation reflexive? 5.1, yep, it is 5.1 that makes it reflexive. So the question is this particular R reflexive?
false.
It is not the case, and what E should I choose to demonstrate that it is not reflexive? Yep, when E equals to 0, 0, 0 in parentheses is in R is false. So we have found one case inside the quantified expression that makes it false. Is that okay? I'm not going to write it unless you guys really want me to write it down. Do you guys want me to write down the answer? I mean, it's going to be this. Huh? Yes.
Okay.
We okay? Okay. All right. What about symmetric? Is this particular relation R reflexive? I mean symmetric. Sorry, symmetric. So we're looking at 5.2. If it is not, then what would be the example? What would you choose as E and F?
I believe it is true.
I think it is. I think it is symmetric. So it would be the answer of symmetric is going to be simple because it's just true. All right. What about anti-symmetric, which is 5.4? Anti-symmetric can be one of those kind of really the more difficult one because it's not intuitive. So um, you get to choose in this case. Yep.
You use the same example as last time. 0, 2.
0, 2 would work, but there's one more.
0, 1.
0, 1 would work as well. Yep. So when E equals to 0 and F equals to 1, it would also fail the test. Because 0, 1 is in the relation, 1, 0 is also in the relation, but yet 0 and 1 are not the same. Is that okay? All right. What about transitive? So we're looking at 5.3. Does that apply? Is it true or is it false for this particular R? This one is slightly tricky, but I think you guys got it.
I think it's true.
It is false. So, okay, so if it is false, what are we going to choose as E, F, and G, right? So I'm going to choose E and G to be 0, and then you can pick your F to be either 1 or 2. So once again, we can make this portion here false by choosing E and G to be 0. F can be 1 or 2, doesn't matter which one. Because you find, there's 0, 1, there's 1, 0. But 0, 0 itself is missing. We also have 0, 2, and also 2, 0. But 0, 0 is once again missing. So I think that's one of the trickier cases is it kind of routes back to itself. Because most people, when they think about transitive, there's an implicit assumption that E and G have to be different? Well, did I say anything about E and G have to be different? No. So that's the tricky part, okay, is most people have this assumption that E and G, they cannot be the same, but indeed they can. All right. Is it comparable? Okay, if you look at this one here, is it comparable? That's actually a very easy question to answer because we already know that it's not reflexive. If it's not reflexive, it means it does not, something does not relate to itself. In this case, it's zero. So if zero does not relate to itself, and you look up the definition of comparable, that means 0 R 0 or 0 R 0 is going to be false.
So that's always the case if it's not reflexive, it's not.
That is correct. But in your answer, I don't want to hear that.
No, yeah, no.
I don't want to hear, well, since it's not reflexive, therefore it is not comparable. So I still want you to explain and use a counter example, but you are correct that it is true that any relation that is not reflexive is automatically not comparable. Okay, all right. So that's question number 2. Question number 3 is kind of flipping on the other side, and I give you just X, and you have to come up with an R to meet all the requirements that is listed here. All right, so let's figure out what this one wants, okay? So this one wants the following property. We want R to be reflexive. Okay, well, right away, I can write a part of the relation, right? Because, let me go back to the text editor. So this is for question number 3. All right, so for question number 3, I can answer one portion of the answer already because R has to have 0, 0, 1, 1, and also 2, 2. Okay, so I can answer at least that part. It is not antisymmetric. Well, there are a few ways to make it not antisymmetric. Having 0, 1, and 1, 0 in it will certainly make it not antisymmetric. It is transitive. So now I have to double check to make sure up to this point it is transitive. I don't have to add anything. It is still transitive, so that's good. It is not comparable. Is it not comparable? Not comparable right now. Well, I mean, it's not comparable right now. Why? Oh, it is. It is. Yeah, it's not comparable because 2 only relates to itself. 2 does not relate to 0 nor 1 in any way. Is that okay? So if I choose E to be 1 and F to be 2, that will make the comparable fail. Because 1, 2 is not in the relation, 2, 1 is not in the relation either. That OR is going to fail. It's going to give you a false. Is that okay? So far so good. We only have one more thing to go, which is it also needs to be symmetric. Looks symmetric to me. Is it symmetric? Yep. So that's the answer. Okay. Question number 3 is just you figuring out an example that has all the properties listed. All right. Moving on to question number 4. So question number 4 in this case and question number 3 are kind of the same format. So we'll take a look at question number 4. Okay, so this time we want what? Okay, once again, we want something that's reflexive. So 0, 0, 1, 1, oops, 1, 1, and 2, 2, they all have to be there. It is not antisymmetric. Ooh, okay, so am I repeating the same question? It is transitive. So that is comparable. Aha, so that's the difference. This one needs to be comparable. And I don't want to add anything just yet because I also want to see if whether it's symmetric or not. So it is also supposed to be comparable and also symmetric. Okay, one thing at a time. How do I make it comparable? What is the minimum that I need to add to make it comparable? Okay, so the focus is on 2. 2 only relates to itself right now. I need to also relate to 0 and also to 1. So that means the minimum that I need to add is going to be Okay, 1 and 2 are now related, and 0 and 2 are also related now. But that's only going to meet the requirement of being comparable. It is now not symmetric. So in order to be symmetric, I also need to add 2, 0, as well as 2, 1 to the whole thing. So now it meets all the requirements. Are we doing okay so far? Okay. Let's look at question number 5. So question number 5 also has a similar kind of question. And this time we don't want it to be reflexive. Okay. That doesn't tell us much, because if you don't want something to be reflexive, all it confirms is 0, 0, 1, 1, 2, 2 cannot be all in the set. Can we have one of them? Sure. Can we have two of them? Yes. We just cannot have all three of them at the same time. Okay, so that doesn't help us too much. We also want it to be not anti-symmetric. Okay, so if we don't want it to be anti-symmetric, then we can introduce these two. That will make it not anti-symmetric. We want it to be transitive. So right now, is it transitive right now the way it is? Remember the mistake that we just made earlier? So the question is this R transitive as it is?
No.
It is not, because if I go from 0 to 1 and 1 back to 0, then I should expect 0, 0 to be here. Okay, fine, we'll add 0, 0. Hmm?
And 1, 1.
And 1, 1. That is correct. Very good. Okay. All right. So next is it is not comparable, which is good because we are definitely not comparable the way it is right now. 2 is not even mentioned anywhere, right? And we also want it to be symmetric. Is it currently symmetric? Yeah, looks symmetric to me. Okay, we're good. Is that okay? So let's take a look at question number 6, which is back to the earlier format, which is I give you the relation and you have to tell me about what is true and what is not true about the relation. All right, so let's start with reflexive again. Is this relation reflexive? Okay, what does it take to be reflexive? Every element in X has to relate to itself. Let's take a look here. 0, 0, 0 relates to itself, 2 relates to itself, 1 does not. So the answer is false, but you also have to tell me that when E equals to 1, E is in R is false. Okay? Next one up, is it symmetric? Okay. So is it symmetric? Definitely not, because 0, 1 is here, but 1, 0 is not. So your answer is going to be false when E is 0 and F is 1. EF is in R if and only if F is in R is false. Okay? Is it anti-symmetric? Looks like it is anti-symmetric. Is it? Oh, you want to look at the definition? Okay. So we are asking whether it is anti-symmetric or not. This is the requirement to become anti-symmetric. It is true, it is anti-symmetric. All right, next one up is transitive. Is it transitive? All right, so we got 0, 1, 1, 2, and 0, 2 is missing. It is not transitive. All right, should I say that one more time? 0, 1 is present, 1, 2 is present, but 0, 2 is absent. So when E equals to 0, F equals to 1, and G equals to 2, then EF is in R and FG is in R implies EG is in R is false.
Can you go over the anti-symmetric one more time?
Sure. The antisymmetric is true. So there's no counterexample that needs to be provided. So one way to look at the antisymmetric thing is to look at every single way you can pair up the E and the F. Now that's going to take some time, right? So the other way to look at antisymmetric is in order for something to be not antisymmetric, you need um, something like 0, 1, 1, 0 to be present, because only that way you can make the conjunction true, but yet the comparison of equality to be false.
Oh, okay.
So in this case, I cannot find the counterpart of 0, 1 because 1, 0 is missing. I cannot find the counterpart of 1, 2 because 2, 1 is missing. I cannot find the counterpart of 2, 0 because 0, 2 is missing. So when they are the same, it's not an issue. It's only when the values within the two tuple is different, I need to look for the counterpart. Is that making sense? Okay. All right. So it is not transitive, and is it comparable? So it goes back to the earlier thing. I don't want you guys to say because it's not reflexive that it is not comparable. So you actually have to tell me that 1, 1 is missing. Um, and to make it comparable, we need 1R1 or 1R1 to be true. But in this case, 1R1 or 1R1 is actually false. Is that okay? All right. And then we move on to the hairy stuff that you guys don't like. All right. All the resolution stuff and turning things into CNF. But these are not nearly as hairy, okay? I know because I wrote the program to generate these. I know how many steps can possibly be the maximum number of steps. So they are not nearly as bad as the homework assignment. All right. So given that psi represents everything known to be true and psi equals to this, so that would be the first thing that we need to turn into a CNF. So let's go ahead and work with this one. All right, so I'll even be clear that this is psi, and we want to turn that into a CNF. All right, so where do we start? What is the usual approach that I do? Get rid of the implication first, okay? So we look at the implication and say, well, by definition, the implication turns into, I know this you cannot do because you're using paper and pencil, but basically what I usually do is I just add a negation here and then turn the implication into an or. And then we simplify because the double negation just kind of goes away. We have not P and Q or not R and Q. Okay. So now we have the opposite of what we want because instead of a CNF, now we have a DNF. Well, it's not too bad here. In the example of our homework assignment, it was really bad because we had a whole lot of terms on each side of the or. So when we need to do the FOIL thing, it just becomes a huge number of things, right? Well, in this case, it's not too bad. Okay, we end up with 4 disjunctive elements. It's just regular FOIL. Okay, so we end up with not P or not R, and not P or Q, and Q or not R, and also Q or Q. There we go. Is that okay? Does everybody understand, how distribution works in this case? And here it is. Okay, this is the answer. And if you want to, you can also simplify the Q or Q, sorry. So Q or Q simplifies to just Q. Okay, makes it easier to write. All right, so what is the next part of the question? The next part of the question, I can now close this one and also this one. So the next part of the question is phi is a proposed theorem, and in this case, phi is this expression. Okay, so we copy this expression into my work area here. This is my phi. All right, what is the first step to do here? What do I need to do first?
Negate it.
Negate it. Okay, very good. Okay, I'm so glad that you guys do remember. This is proof by contradiction. which is we have to negate the proposed theorem first before we convert the negated proposed theorem into a CNF. Okay, so we say not phi is going to be the negated version of this. Okay, so the negated version of that. All right, so now we can do all the work to convert this into a CNF. So I will leave the negation alone, get rid of the implication, turn it into an or, like so. And now I have to do the, I think the next step is going to be using De Morgan's law in the inside. So now we end up with not Q and R. And then on the other side, I can apply De Morgan's law too. It becomes not P and not R. Not R, sorry. There we go. And then we can do some simplification. So this becomes just Q and R on one side, and then becomes not P and R on the other side.
Shouldn't it be Q and not R? For the Morgan's law, you forgot to negate the R, the first R.
Oh yes, you mean this one?
Yeah.
Yep, you are correct. I forgot. So we still have a not here. And then we apply De Morgan's law one more time. So this time we end up with the negation of Q and not R, and the negation of not P and R. And then one more time to perform De Morgan's law, not P or not R, and not P or not R. And then clean it up a little bit, becomes not Q or R, and P or not R. And that would be the final form. Are we doing okay so far? Or did I make another mistake somewhere?
For the last negation, line 3 from the end,
This one?
that one, yeah.
Uh-huh.
Why did you negate not PR?
This negation applies to the conjunction between not P and R. There's a negation here.
Yeah, but why?
Why?
Why are you negating it?
Because it came from above. So I distributed this particular negation to each of these two terms. So this negation, the one that I'm pointing, okay. I'm just concerned about people who are watching the video. So this negation applies to this or, right? So that means, in order to apply De Morgan's law, I have to negate this thing as a component, and I have to negate this thing here also as a component of the original expression. And that is why we have the negated version of not P and R.
Oh, it makes sense. I didn't see the parentheses.
Oh, the parentheses?
Yeah.
Which pair? Oh, you mean the outermost pair?
Yeah.
Yeah,
Because
yeah.
I negated only the first.
I see. Yeah, the parentheses are super important, and it's harder to match when you don't have an editor like the one I'm using right now. When you put it on one open paren, it matches the close, and if you put it on the close, it matches the beginning. All right. And I'm just double checking right now. Yeah, okay, that looks good. That looks good. Okay. All right, so now we can apply, we can concatenate the two CNFs and then apply resolution and see if it applies. So I'm going to have to change the way this works, because you guys are all going to be writing, and not typing. So that makes copy and pasting impossible. So I have to figure out a way that makes it easier for you guys when you are just writing it. Okay. The resolution part is probably doable if you are just writing, because you can just identify which two you are, resolving together, and identify what is the connection between those two. So that shouldn't be too hard. Okay, so how would we go about doing it? Because what we're trying to do here is to find out, on one side we have something, on the other side we have the negated version of that something. So there are several ways we can apply this. Um, let's see. Oh, I take it back. We do not actually have too many ways. So R is one of those things that we can actually resolve. Q is also one of the things that we can resolve in P also. Okay, so I take it back. We have quite a few ways to do the resolution. And let's see here. So we got P. There we go. Okay. Um, this one can resolve to 0. I can already see it. Okay. So you can do the systematic way. You can also kind of do it the not so systematic way. So we can see there's R and there's not R, and we want to single out, R or not R to be on its own. In other words, we want to single out, either P or not Q kind of on its own, Q or not R or not R on its own, and also either P or not P on its own. Well, because Q is already by itself, so it would kind of seem to make sense that we can try to single out not Q. In other words, we want to single out this not Q. That's the only occurrence of a not Q of the entire thing. So that means this R has to go away somehow. So this R can now resolve with this not R here, or it can also resolve with this not R here. So the question is that going to work? If this R resolves with this not R, what is going to happen? We end up with Q or not Q inside one disjunction. And what is that? What is Q or not Q? It simplifies to true, so that's not helpful to me. Okay? So that means if going this route using Q is not going to work. So Q cannot resolve to a 0 because there's no way for me to single out this not Q from the whole thing. Let's see, can I do that? Okay, if this resolves with this one, we have P or not Q left. So can I get rid of the P or not Q, and if I resolve with this one, I still end up with the true. Yep.
Something is certain isn't implied.
Okay, hold on, Anthony, go ahead.
Oh,
Yeah.
was he speaking or was I?
Anthony, yes.
What's stopping you from saying isn't Q or not R and not Q or R? Don't they cancel each other out?
Okay, let me try to make sure I understand. So you're asking whether this will cancel out this one.
No.
No.
Oh,
Q or not R and not Q or R.
Q or not R, which is this one,
Yeah.
would it cancel out this one here? You can only resolve one variable at a time. Okay, let me point out one more. Okay, so let's do this. Okay, let's resolve these two. It's not going to hurt anything. It's just maybe it's just not going to work out the way that you imagine it will work out. So I'm just using this to indicate which two we are resolving. Now you have a choice. Are we using Q or are we using R? You cannot use both at the same time. You can only use one at a time.
Say Q.
So, okay, let's use Q. Okay, so I am going to change my highlight to indicate which one I'm using. So this is what I'm using. This is what I'm using, right? Okay, so what is the result of doing that? Doing this one? What do we end up with? Not R is on one side, R is on the other side. Yes?
I think you did a mistake on negation of 5.
The negation of 5. All right, okay, let's
Because
turn.
you negated R, but then you didn't negate P.
Okay, let me turn out the line numbers. Which line are we talking about?
5.
Line,
Yes.
this line? Okay, these are the line numbers. So which line are we talking about? Which line contains the error?
Actually, never mind. I take it back.
Okay. I mean, I'm not challenging, whether I made a mistake or not. I could have. I just need to know on which line I might have made a mistake.
Oh, I thought you negated R twice, but not T, but now I see why.
Okay, on which line?
Yeah, that line.
This line?
This the upper.
This one?
Yeah.
Okay, so on that line, this is why, being in person is more helpful because I can actually use my finger and then do this, do the bracketing thing. So to go from this line, um, this is just a simplification, right? I'm getting rid of the double negation to become just Q. I'm getting rid of the double negation, so that becomes just R. That's the transition from line 4 to line 5. Is that okay? All right. Okay, so Alexander, you were you okay? Okay. All right. All right. So this one, just resolve. This one does not resolve, but it becomes 1.
So it's, okay, so that'll be not R and R because those are conjunction statements.
No. But okay. So what is resolution? All right. So what is resolution? What is on one side and what is being implied by the other side. So when you look at resolution, I can't really type the Greek letters very well, so I'm going to use A, B, and C. So it basically says if you have A or B in one conjunction, on one side of the conjunction, on the other side we have not B or C, this implies A or C. That is resolution. So B itself can be complex. It doesn't have to be a single variable, but then you also have to negate the entire expression of B on the other side. So the way we have it here, the negation can only be applied to a single variable, so we can only get rid of one variable at a time. So when you have a situation like this where we have Q or not R on one side, and then we have not Q or R on the other side, you have to make up your mind to say, which one do I use as a connector, and what is the leftover after the resolution? Is that okay? So if we choose to use Q as the glue, as the part that joins the other two, then Q, not Q, will be removed, but then not R, R will be concatenated using an OR. Because that's what resolution does, is it joins the rest of each disjunction by an OR. Is that okay?
So for this one, we would have accepted is if we got rid of the R's and just got left with negation Q plus Q.
Sorry?
No, so with this one, if we wanted to, we could get rid of the R's and keep the Q's and the negation
Right.
Q.
The other way around is not going to work out the way that we want it because we want to get to a 0, right? But it's not going to work out because if you choose and say, we are not going to use Q, we'll go ahead and use not R, then we cannot choose not Q, right? We have to choose this R here. Then what you will have left is going to be Q on one side and not Q on the other side. And as a result, we still end up with a true, which is useless in a conjunction because true and blah blah is just blah blah. Yep.
So what disjunction would result to a 0?
Well, that's what we're trying to work out, is to find a way to resolve until, okay, let's get rid of this, okay, because we know this one is not working. So if Q is not going to work out, we can try to see if we can single out R. Okay, so I'm just doing this in my head. So if we are to single out R, how can we do that? To single out this R, I can resolve Q, not Q, then I can single out the R, right? So that means I now need to think about how do I single out a not R. So to single out a not R, I can use this one, I can use this one. So which one is going to work out? This one is going to work out because I can resolve this one with this one over here. I do apologize for people who are watching the video because they have no idea where I'm pointing to on the screen. So I'm going to do that, okay? All right. So I know that's going to work. So let me show how I can single out the R. So the first step is to single out the R, which means I'm using this Q here to resolve with this not Q and single out this R here. So this particular resolution is going to give me a single R as an expression. Is that okay? Because one side has used up everything that it has for the resolution. It has nothing left over for the concatenation. Okay, all right. So that means, I can, okay, just for clarity, I know you cannot do this when you're handwriting everything, but just for clarity, this is what I'll do. Because I'm just going to append R over here, because that's what we end up with here. Okay, that's not a 4, it's supposed to be an R, which is the key right on top of R. All right, so now what do? We need to single out the not R. To single out the not R, I am going to use this not P versus this particular P over here. Oops. Okay, does everybody see how these two can resolve? Because on one side I have a not P, on the other side we have a P. So now they can resolve. So now we have to kind of look at the leftover. The leftover from this side is just a not R, but the other one also has not R as a leftover. Does that make sense? This is the result of the resolution. So, but this is redundant because I can now look at this and go like, oh, that's just the same thing as not R. Is that okay? Does everybody understand how I single out the not R term? Okay. So once I have the not R, so once again, I'm doing something that you cannot easily do with handwriting. So we'll go ahead and do it like this. So we concatenate everything. The result of each resolution is concatenated to the original, to the entire CNF. So now we look at this and go like, oh, okay, these two can resolve. So I look at this R, I look at this not R and say, they can resolve. The question is, what do they resolve to? So from the perspective of a string concatenation, they resolve to an empty string, which is kind of like, well, how do we write? Just open and close paren? No, that's not quite what we do. Because with every single disjunction, you can always say or 0. You can always append a or 0 without changing the meaning of each one. So that means this one, I can say it is a or 0. This one also has a or 0. So with that, when we resolve these two, what do we end up with? Then we end up with a 0 or 0, which is really just a single 0, which is false. And because this false can be concatenated to the entire CNF, that means the entire CNF is false. Which let us, just give me one more second to finish this part and then I'll answer your question. So that gives us the rationale to say the proposed theorem phi is a theorem. Yes, go ahead.
Wouldn't not P or not R be removed with P or not R?
Okay, say that one more time.
Um, the first expression, not P or R, not R, wouldn't that be removed?
No, it does not need to be removed. Everything that was in the CNF continues to be in the CNF. The result of the resolution gets to be appended to the CNF. So the CNF gets longer and longer and longer. Yep.
Just to clarify the quick process. You want to isolate the inverse of a variable, and it's the variable itself, and then you can resolve it to 0. It's like if you want to resolve to the point where you get like R or not R, or R and not R, and Q and not Q, for example, whatever works.
Yes, but we are not looking at this from the perspective of simplification. We're looking at this from the perspective of resolution.
So before actually getting false, you want to look at all the stuff in your CNF, and you want to try to pull out like R. If you have R, you want to pull out not R.
Correct.
Yeah. Okay.
So you only have so many variables, right? So you look at each one and you ask, is there a way for me to single out this thing by itself. And then you look at the negated form of that variable, and then you ask the same question: is there a way for me to single that out? Now, you may be able to work this out in your head. I would probably not advise trying to do that. So the question is, how do you kind of put it on a piece of paper? You can always use arrows, okay? When you're on the piece of paper, you can always use arrows. That makes it actually even easier because you can now say, okay, this and that, and draw two arrows and then put a new term over here. So that makes it, not necessary to copy and paste anymore. You just keep appending the results of additional resolutions. Is that okay? But did I answer your question? Okay. Does everybody understand the process of doing this? Psi, you don't negate, you just turn psi into a CNF. Phi, which is the proposed theorem, you negate it first, and then you turn the negated phi into a CNF. You concatenate those two CNFs, and then you use resolution. When do you stop? 1, you get to a 0. Congratulations, you found that phi is actually a theorem. Or 2, you try to resolve as far as you can go, and you cannot come up with anything new anymore. Then you also can come to the conclusion that phi is not a theorem. Is that okay? That's kind of the process. I mean, the homework is a killer, which has to do with the complexity of the expression, but the approach is the same. This has the very same approach as the homework assignment, except the number of steps to get to the CNF is definitely limited. Are we good so far? All right. Do you want me to work out another example? Okay. So the next one is this one here. So we look at psi. This one looks a little bit more challenging, which is good. All right, so we take this out and try to convert this into a CNF. All right. Well, I guess I will do distribution first. Okay. There are a few ways to do this. All right, so we'll take a look at this one, not P and not Q, or not Q. And then I'll do distribution here, which is RP, and then we have R not Q. So this is just one distribution, and I got rid of the parentheses that are not needed. All right, so now we have a DNF again. So with a DNF, you can just kind of do the superfoil, which means, you just expand it, it's kind of like a Cartesian product. In many ways, it's like a Cartesian product. So you end up with not P or not Q or R as one thing, and not Q or not Q or R or R. You can also do this more incrementally if this is like too difficult to track. Okay, let me do this more incrementally. All right, so to do this more incrementally, you just basically look at one single conjunction and distribute and turn it into a disjunction, into a CNF first. So let me put extra parentheses here because this way it's more gradual. Okay, and now it becomes not P or not Q and not Q or not Q, and then the rest will still be the same. Okay. And we can do some simplifications. So this becomes not P or not Q and not Q, and then the rest would still be the same. Okay. And then we group these two. So we look at this and say let's group these two into one. So now we have not P or not Q, not Q, R. Let's see. Nope, the whole thing or R. And not P or not Q, not Q, and P or P. Let's see. Or P. There we go. Need. And open thread here. All right. So, what do we do here? Oh, we can distribute a not R into each term. So now we have not P or not Q or R and not Q or R. I'm just double checking to see if this is working. So we distribute the R, the or R into the existing terms. Okay, that works. And then we have not P or not Q or P and not P or not Q. Nope, not Q and or P. There we go. Yep. All right. Okay, and then we have the R not Q. Okay, same thing, except we can probably simplify. All right, so if we are to simplify, where do you think we can do the most simplification? Well, we look at each term and you can tell me whether we can simplify or not. If we look at these two, is there a way to simplify? Do you see not Q or R is in both of them, right? So that means the first term is like the second term, except it has or something. And then these two disjunctions are in a conjunction. So which one can we get rid of? Okay, so I'm giving you a clue already. We can get rid of one of them, but which one can we get rid of? It's a conjunction, which means things tend to become more restrictive or more specialized. One of these is more general, so which one can we get rid of? Okay, to cast this problem in a different way, we are basically saying we have A or B and A. So is this the same thing as A or B, or is this the same thing as just A? um, shall we use a truth table? Okay, so we have A, B, and then we have A or B, and then we have A and A or B. So we'll work out the truth table, the entire thing. Okay, false, 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 true, true, false, and then true, true. So A or B is going to be true, it's going to be false only on the first row. For all of the other rows, A or B is going to be true. So now the question is, what about A and A or B? The first row is going to be false, that's an easy one. What about the second row? It's going to be false. What about the third row? False. The last row is going to be true. So you tell me which one can we simplify out? Which one is not contributing anything useful to the whole thing? If I were to convert A and A or B and get rid of one of the two terms in the conjunction, which one can I get rid of? A or B. The entire A or B is out because this column is the same thing as, oh, wait, hold on a second. Okay, I think I might have made a mistake with A or B. No, I did not. And we're looking at A and
It's true and
Oh,
true.
I missed one. I missed one. Yep. I missed one. That was my mistake. There we go. Okay, now we're better. Do you see how the first column, which is A, and the last column, which is A and A or B, are actually the same, right? So that means I can get rid of A or B. So that means in this case, I can get rid of this. Okay, let me just pause here, make sure everybody understands how I came to the conclusion that the highlighted portion can be removed without harming the meaning of the entire expression. Are we good so far? Yes? No, maybe? This portion here, not Q or R, is our A. Not P is our B. So once you match that pattern, then we can remove A or B, which is the entire highlighted portion. Is that okay? Yep.
So the same thing be done on the other side?
Yep.
Not here.
Yep. Yep. Isn't that nice? So this one becomes just like that. And then, oops, I think I removed one too many things. There we go. So on the other side, we have the same thing. This more general, um, this is the more general term can be removed. So now we just have to distribute over R and not Q. So see. We have the and. Okay. All right, so we'll do it the slower way, which is this whole thing or R and not Q or R and not Q or P, and then the whole thing or not Q. There we go. Okay, that works. So now we distribute the or R into everything. So we have not Q or R and not Q or P or R. On the other side, we have not Q or R or not Q and not Q or P or not Q. So that's easy to do because now we can also simplify a whole bunch because now we have not Q or R and not Q or P or R, which is potentially simplifiable. And then this one is just not Q or R because we have not Q twice in the same OR. And then this one is the same thing, just not Q or P. And now we do one more simplification because this term is the more general version of this term over here. So we can simplify that out. So now we have not Q or R, not Q or R, which is a repetition, and then we have not Q or P. Yep.
Observation rule.
Hmm?
47.
For line 47.
Observation rule. Observation. May,
You can point to the screen if you want to. Oh, wait. That's a permanent marker. Hide those. Nope, cannot use those. I have no idea why they put permanent markers next to a whiteboard.
47.
Well, right here.
Ah, 47, I'm sorry.
Hmm?
EQ.
It's the same.
EQ. What I see. This, I see.
Well, okay, so I think
I see what this.
okay, I see you want to
I
simplify
see.
this one. It is simplifiable. Okay, so let me do this. Would you mind if I just do this? Because I think there's a way to simplify this earlier.
Yes, okay. Okay. EQ. This different.
What?
EP, EQ plus EQ.
Hmm?
Нет. I'm
Okay.
sorry.
That's okay, not a problem.
Maybe my eyes. I see different.
Okay,
I probably my eyes. I'm sorry.
no problem. Okay, so I have to admit that there's an easy way to go about this whole thing, because earlier I could have simplified. This can be simplified. So the question is, okay, if I tell you one of these two conjunctions can be gone entirely, which one do you think can be gone? These two are connected by or, which means we want to make the whole thing true more often, right? So which term can we get rid of without changing the meaning of the entire disjunction?
I'm sorry. 46.
Line 46.
Accept rule obsession. Is this rule absorption?
Absorption. Uh-huh.
Absorption. This absorption.
Yes.
Zico.
Yes, that's what I'm trying to.
EP. Then
That's what.
this IP.
Yes.
This IP.
That's what.
This absorption again. If
That's what I'm trying to demonstrate now. Okay, so this group has a name, but I want to explain what it is first. Okay. So which term can I get rid of? Just of the highlighted portion, I can get rid of one of those two terms in the disjunction. Okay. Same trick. Use a truth table. Okay. If we don't know how to figure this out, use a truth table. So we have A, B, or just one of those two. I would just call it A. So once again, we have a truth table, 4 rows. A and B are independent. So now we have, this, the whole thing is going to be 0. What about this one? Still going to be a 0, right? Because A is a 0, so A and B is a 0 to begin with. A is still a 0. This one is going to be true. And this one is also going to be true. Okay, something is not right. Okay, let me just double check here. So A is false, B is false, A, B, or A has to be false. Okay, not a problem. A is false, B is true. So the whole thing is still going to be false because A and B is still false. With this one, A is true, so AB is true, and so is, nope, I take it back. This one is, nope, this one is true.
Shouldn't that be false?
Huh?
You need A and B is false.
Yeah, but we also have or A here,
Ah.
right? So because of the or A, this is still going to be true. So this is the last one. So that means AB or A is just A. Okay, do we see the same thing? This column looks exactly the same as this column here, which means A and B within the disjunction serves no purpose. Okay, so we can get rid of that. So, so that means earlier we could have gotten rid of this term.
absorption.
It is called absorption. Thank you. So
Again absorption.
and then so we can absorb again, right? Because between this not Q and also this one here, we can absorb one more time. Okay, let me double check with the class. Okay, do you guys see how we can absorb again? So if we absorb again, it becomes just that. And But this is still not in CNF, is it? This is in DNF form. So now we do the final distribution, which is not Q or R and not Q or P, which is the same as the long route. Scenic route. But yes, we could have used absorption. Yep. All right, we're running out of time, but that's kind of those three questions have the same format. So it's the same approach. Yes?
Are you gonna have, this on the modules, the practice exam, or are you gonna have it on
Well,
it?
this is just the exam from last semester. I still have not decided on what your exam is going to look like, because I have to take into consideration that yours is on paper. This was online, so people could copy and paste. It makes certain things easier to do. So when yours is on paper, I cannot make the same assumption, because this is going to take up a lot more time just to write out everything.
No, sorry, I was just asking if there's just practice one to do, like.
Oh, you want
over the
more
weekend.
practice?
Like over the weekend,
I can give you more. Can you send me an email just to remind me to kind of send you more practice?
Just like last year's exam, right?
Okay, yeah. Question?
Oh, no, I was.
No? Okay, all right. Yep.
Someone left their phone over there.
Uh-oh,
Yeah.
that's actually mine.
Oh.
I was walking over there because there was a student presentation, but thank you.
Oh, okay.
Yep, thank you. That's funny. All right. Questions? It looks like you have a question.
I had one, but I forgot.
Hmm?
I had one, but I forgot.
You forgot? Okay.
Oh, for each step, should we like explain what we did?
No.
Okay.
Not when it's on paper.
Yeah, because I was like,
Yeah,
that's gonna take
because
way
if
too
it's
long.
on paper, your score is going to be limited by how fast you can write it. That would not be the right thing to do an assessment. Yeah. Yeah, I think I'm gonna have to change the format of what you guys are getting. Instead of having you guys to write out the derivation, it has to be in some other way. Yeah. Which means, I need to kind of think about it, of how to make the test.
I was gonna ask where you asked us to start with the step where we will now call it.
Mhm.
We asked us to show us the explanation behind it, because if that is the case, we have to basically do a truth
Okay.
table every time, right? Is that, or can you just say by absorption, reduce it, like,
That's not a bad way to test, I give you the derivation, and then you guys just identify, what did I use, in that step. And then I'll give you a code, like, A is this De Morgan's law, B is that De Morgan's law, C is this distribution,
oh,
D is
like
this
matching?
distribution. Yeah, then it's just matching, like, okay, you use this one A, this one is D, this one is C, oh, and then you use C again. That is doable, I think I like that. The question is, can I still remember when I get home?
Like, do I have to like derive it for like this stuff right here?
Uh-huh.
Would we have to be like this when we distribute? Should we be super explicit and be like, bigger than 3 plus 3 plus 8? Can we just like simplify it instantly? Or like,
Well, that's what I said, because, I don't want you guys to have to do the derivation on paper, because that's just brutal, because, now, some people write faster and other people do not. So instead of doing that, I would just give you the proof, and you guys identify what did I use from one step to the next.
Yeah.
That would be doable, because that just, that depends on how fast you can read and how fast you can recognize the pattern, but not how fast you can write.
Yeah, because knowing myself, I'll write every step, and I don't write fast, so.
But I like the scenic route, you came to the same point. Which means, there's no only way to do something. Yes, there's a faster way, yes, that is true. But you can also do the whole thing, and then.
Actually, I missed how did you do the absorption for the second part,
The second part?
the RP part?
Because of the Q. Because you have RP and then also R not Q, so the Q absorbs the R not Q.
You're using the, oh, you're just using the Q that's, okay, so it's not the, yeah, what's it? Yeah. Form P and this normal Q within your, okay, I see now. Wait, no. Hold on. Write that down. Good.
Okay, so I think what I did was this Q absorbed this whole thing.
Yeah, that we.
So I only got this Q, and then this side is untouched, right?
Mhm.
And then we wrote out, RP, and then yeah. So I it would be more clear if I expand it a little bit. So we can end up with not Q or RP or R not Q. This R not Q is the one that is absorbed by the not Q. So if I write it in a slightly different order, it'll be more clear. So if I move that thing out of the way, so now these two are adjacent. So now we can see how these two just becomes not Q. Because in a disjunction, the more restrictive term is useless. The conjunction makes R not Q more restrictive, and therefore it doesn't need to be there. Or we can also use the truth table proof.
Yeah. I see, okay, now that makes sense.
So that took care of the R not Q, which means we only got RP left. Yeah, because in class, I just did this, I highlight and then I just delete.
Yeah.
So that's why, when you look at it statically, it's like, how did we get here? You have to watch the entire movie to see how we got there.
Yeah, because I did that first half on my notebook, and then,
Mhm.
okay, that checked out, right? But
And then,
I kind of look up and
and
down,
then you turn, and then you turn
disappeared.
your head and it's like, what? What just happened?
Yeah.
Yep, there we go.
Okay,
Yeah.
that makes sense.
Okay. All right.
If it's not a theorem,
Mm-hmm.
we gotta show each resolution that can happen, right?
Right. So technically that is the case. So I'll have to change the format once again, because I don't want you guys to have to write out a lot of stuff, so that your writing speed becomes your limit.
Yeah.
Yep. This is the first semester that I conduct, this test. Well, after 2 years, with paper, with a paper test. So I have to readjust a lot of the formatting of the questions.
All right, well, that's all I
Mhm.
have to ask.
Okay. I think I can turn off the recorder now.